on identity problems on the back side here. Remember, this is where we're trying to write everything in terms of sine and cosine. If you can distribute first, distribute. Then try to change things to sine and cosine. And don't forget about your Pythagorean identities, like sine squared plus cosine squared equals 1, things like that. Let's go down to letter A and see what we can do. The first thing we're always going to try to do is distribute. Can I distribute here? Yeah, so I'm going to do it. Sine times that, sine times that. So sine theta times cosecant theta minus sine theta times sine theta. What am I going to get when I take sine theta times sine theta? Sine theta squared or sine squared theta. Sine squared. Everybody good to there? You can remember this probably, but I'm going to write it out just so we know. Sine. Cosecant, right now that's not in terms of sine. How is cosecant related to either sine or cosine? It's the reciprocal of sine, so it's 1 over sine. I've got sine times 1 over sine. I'm multiplying reciprocals. What happens when I multiply these together? They cancel to get you what? 1, not 0. It's there. It's 1 minus sine squared theta. I got to hang my sign back up. But it's 1. You see ones and you see squares. Where should your eyes go? Your Pythagorean identities. Remember, those are on the back of your unit circle right here. Pythagorean identities, top corner. I see 1 minus sine squared. What can I put instead of 1 minus sine squared? Cosine squared theta. That's my answer. I want you to keep simplifying. It'll probably be a multiple choice question where you have to be able to identify it. Kamara, you have a question? Okay. Okay. We good? Pythagorean identities? Yeah, that's up there. It's on the top. Next one. We are solving. So remember, anytime we are solving these problems, we are doing PEMDAS in reverse. We are trying to get theta by itself. We are doing PEMDAS in reverse. Letter A, I don't know if it's equal to 11 or not. Is yours equal to 11? Yeah. Here we go. 4 cosecant theta minus 3 equals 5. We are trying to solve here. The directions are solve. All the answers between 0 and 2 pi. So the key to this is we are doing PEMDAS in reverse. Remember, we're trying to add or subtract stuff, trying to get rid of things until we get theta by itself. So the first thing we're going to try to do is add or subtract. From the theta side over here, is there anything I can add or subtract? This 3 right here. I want to get rid of that negative 3. So to get rid of it, I'm going to add 3 to both sides. So it's 4 cosecant theta equals 8. Great. Step 1's done. Step 2 is, all right, added or subtracted. Now we're going to try to multiply or divide. Is there anything being multiplied or divided on the theta side? There's a 4 right there. It's being multiplied. What am I going to do to get the opposite of multiplying? Divide by 4. Divide by 4. Great. That goes away. I get cosecant theta equals 2. Cool. Did multiply and divide. Not really any exponents here. There's one step here that's not necessarily listed in PEMDAS. I don't like doing cosecant. Okay, cosecant is weird. What can I do instead of cosecant? Sine. Cosecant is the reciprocal of sine. So I'm going to change cosecant to sine. Well, if I do that and I make cosecant sine, I did the reciprocal. That means I have to do the reciprocal to the other side as well. That's going to be a half. So I took the reciprocal of cosecant, I took the reciprocal of 2 and got 1/2. Now I still need to get theta by itself. What do I need to do to get theta by itself?
Are you saying that you just put the 1 on top of the 2?
Yes. To get rid of sine, I'm doing the opposite of sine, which is inverse sine. Which you remember, all that means is you're going to your unit circle and you're trying to find everywhere, and I'm talking everywhere, that y over r is 1/2. So I'm looking at my unit circle. I'm looking for everywhere that sine, y over r, is a half. 30 degrees. At 60, x is 1/2. 30 degrees, where else is sine going to be 1/2? 150. Those are my two answers. Remember on these, there are normally two answers for them. Oh, it would be, yeah, we did do those in radians quite a bit. It wouldn't matter. It would be multiple choice. What did I write up above? I put theta. Oh, yep, I should have done radians. Sorry. Up above it said 2 pi, so I should have used radians. Pi over 6 and 5 pi over 6. Same difference. I wouldn't necessarily count off for the other one, but yeah, that's a good point. Questions there? That's it. Number 7, we are simplifying. So this is easy math. These always look harder than they actually are. Letter A, let's just do it. 5 times cosine of 90. Go on your unit circle. Go to 90 degrees and figure out what cosine is. Here's 90 degrees up here at the top. If I'm doing cosine, which one of these numbers do I want, x or y? X. X at 90 degrees is 0. Plus 3 times cotangent at 135. Cotangent at 135, that's right here, 135. Cotangent is x over y. No, you're right. X over y. So if I wrote x over y there at 135, it's negative radical 2 over radical 2. That's x over y. What's that get us? Negative 1. I got a radical 2 on top, a radical 2 on bottom. That's negative 1. You do have the tangent numbers written in there as well. So that's tangent. What would I need to do with that negative 1 to get cotangent? Do the reciprocal. What happens when you flip negative 1? It's still negative 1. This is negative 1. Cotangent at 135 is negative 1. If that confuses you, do x over y. That's not hard. There's my setup. What's 5 times 0? What's 3 times negative 1? 0 plus negative 3 is negative 3. That's just plugging in and using your unit circle. Last one, and I don't know if I have enough time to get it in. We're going to be in a hurry here. That's an extreme example up above. This is the hardest one of the day. Tangent 2 theta equals negative radical 3. We want to get theta by itself. So the first thing I need to do is get rid of tangent. So to get rid of tangent, I'm doing inverse tangent. Is that what yours says? Okay. I heard somebody said something different. 2 theta equals everywhere that tangent is negative radical 3. So I'm looking at the burgundy numbers up here on my board. Yeah, we're going to do radians here. So 2 pi over 3. And what else? 5 pi over 3. Those are the two answers. And in a perfect world, I'd be done. But theta's not by itself. What is still with my theta? 2. What does this 2 mean? 2 times around. Remember, that was the whole Ferris wheel problems that we spun around twice. You're going twice as fast, so we're going to have 2 times answers. So remember what we do. We add 2 pi to my answers because I'm going around again. I'm going to add 2 pi. But I need to add 2 pi to these numbers over here that have denominators of 3. So remember, the next thing we did was we found common denominators. What do I want my denominator to be? 3. This was 2 pi over 1. What did I do to make a denominator of 3? I multiplied the bottom by 3. So what's my top going to be? 6 pi over 3. All we're going to do now is we're going to take this and add it to these two answers to figure out what I get the second time around. So 6 pi over 3 plus 2 pi over 3 is going to be 8 pi over 3. We don't change the denominator when we add fractions. We just add the top. And then 6 pi over 3 times 5 pi over 3 is 11 pi over 3. Almost done, but not done yet. What do I still need to do? I don't have to do it again because it's just 2. I've got 2 sets of answers. That's my first set of answers. That's my second. I still have to do something at the bottom. It was 2 theta. How do I get rid of the 2? Divide by 2, which is the same thing as multiplying by a half. So my final answer is I could reduce this 2 pi over 6, or I'm just going to say pi over 3. 5 pi over 6. 8 and 2, I could reduce that to get 4 pi over 3. And 11 pi over 6. I can't reduce that one. Yep. 5 pi over 6, because it's 5 pi on top and 3 times 2 on bottom. There's my answer. January